afternoon, everybody. Oh, I can see everybody is still asleep, clearly, after lunch. I think I was warned by the two Stellenbosch students who are here that people would be asleep after lunch, and that I should therefore start with a joke. So I'm going to share the joke that they told me to begin with, which is, and correct me if I'm wrong, which capital city in the world has the largest rate of population growth? I don't know the answer. No? Vatican? No. Dublin. Because it's Dublin. Thank you. Okay, that's got you awake at least. I'm getting a little bit more response from the audience than I did half a second ago. So Pete called me, I think a few months ago, with this idea of engaging with, he said we're going to set up a session where we're going to engage with the paper that's been written by Kuno Grafmeier in the group. And I said yes immediately, almost before he told me what else was going on. Because I'd read this paper a year and a half or so ago, and I liked the paper. And I liked the paper because there's something very comforting about reading about a problem that you recognize. And that was my first instinct on reading this paper. It was kind of, thank heavens that other people in the world have got some of the same problems that we have. Because in South Africa, I think we think of ourselves as having more problems than anybody else. So it was lovely to read a paper from another part of the world where a problem that we recognized as being spoken about. So, just to remind you, that first slide is doing funny things there, but hopefully the rest will be okay. Just a reminder of how in that paper they define or describe this idea of task propensity. And they talk about the tendency to think of instruction in terms of individual tasks that have to be mastered by students. And we've already heard quite a lot about that idea this morning. And certainly in South Africa, we've seen some of that, and I'm going to share a little bit about the ways in which we've seen that problem manifested in our South African data. That's not a problem which I think in any way is restricted to the Dutch experience that Kuno was talking about. So another work that I'd read earlier on, and this one comes from Anne Watson and John Mason's work, where they use variation and the ways in which traditionally teachers work with examples. They make a caveat and they say that any task, but including and particularly problem solving and modeling tasks, can focus learners' attention to the immediate doing, which is the calculations or the representations and etc. And unless special steps are taken to promote further engagement, there is seldom motivation for abstraction, rigor, or conceptualization beyond that necessary for the current problem. And I think in some ways that's heading towards the same kind of concerns that have been thrown up in the Dutch experience. Well, do we recognize that kind of problem in the South African context? And I think we do. And the paper that I like the best, or the work that I like the best, actually came out of Jill Adler's project. And Craig Panara is here, and they worked together in a research and development project focused on secondary maths. And in some work that we did a couple of years ago, Jill, a paper that I wrote with Jill, we looked at this set of examples, which they saw being used in a lesson. So you can see the series of examples being used. Question 1 was 4 bracket x plus 2, then 4x bracket x plus 2, minus 4x bracket x plus 2, another example in the middle, and then question 5 was x plus 2 bracket x plus 3. And the teacher worked with each of these examples in the ways that you can see. She did them on the board with learner input. Now the point that was made in this book chapter was that what we could see when we tried to analyze the classroom narrative was that there was what we might call structured variation. So you can see that something is invariant across all of those examples. The multiplying by x plus 2 remains invariant across all of those examples. It does open up the possibilities of kind of allowing the effect of the multiplier on the product to be discerned, if we spend time attending to that. But the comment that was made in the chapter, that the narrative associated with working with those examples, this is the instructional narrative, suggests disconnection. And what we saw in that lesson was, rather than a narrative that connected between those examples, we saw a narrative which said, and now we're going to do a new example, and now we're going to do a new example. And actually when question 5 came up, The teacher says, now we're going to do something completely different. We're going to talk about the distributive law. So the comment that was made in that chapter was that the products of expressions are presented in discrete parts, each associated with a different rule of operation. Now that echoes something that Kuno said in the paper and he showed us this morning, that by the time in the fractions examples that he talked about, that different rules are presented for a connectable series of examples. Okay, so a very similar problem was seen in that particular episode. But, and Alvin's presentation earlier in the day pointed this out, while we have overlaps on that particular problem, that doesn't mean that our contexts and our cultures of instruction are the same. So while we do have some elements which overlap, and particularly I think in terms of task propensity, we can see some overlaps, there are other issues which are perhaps more particular to the South African terrain that we need to engage with if we are going to engage productively, I think, with dealing with the task propensity problem. One of the problems is we can start to see it in the teachers highlighting of now we're going to do the distributive law. And this kind of relates to an issue that was talked about for the people who were here yesterday, and it was brought up again today, is that there are issues in the South African terrain which have been written about widely about gaps in teachers' content knowledge. Okay, we know from the evidence that we've got and from several studies over an extended period of time now, close to 20 years, that the task propensity issue in South Africa we think is compounded and complicated by evidence of gaps in teachers' mathematical knowledge. Those gaps, where the studies have been done, the evidence suggests that those gaps are at or close to the levels of teaching, and we've seen the evidence in the middle grades and beyond that. I'll come and talk a little bit later about slightly different issues, I think, in the very early grades. But in the middle grades and beyond, our intermediate phase and beyond, there's evidence that teachers actually have problems doing the tasks that they are trying to teach. And we've got evidence of that from the SACMAC data, but from Martin Carnoy's study and other studies as well. So what we see on the ground in South Africa is content knowledge issues feeding into a sidelining of higher cognitive demand tasks in teaching. And Ingrid's work points to some of that when she looked at data sets, quite large data sets, of classroom teaching where higher cognitive demands were almost in absence along the way with a highly procedural kind of orientation to teaching. There has been, and probably more so about a decade ago, quite a lot of evidence of limited coverage of the curriculum. This has been talked about a lot in the implementation of Curriculum 2005 and the revised National Curriculum Statement, lots of studies pointing to limited curriculum coverage. And what that has meant in the last 8 or so years is an increasing curriculum revision which kind of prescribes to teachers the rate at which they need to proceed with the curriculum and cover the curriculum. And the danger with that is a danger which many of us who work with teachers see quite often. We get teaching happening and teaching marching on, but not necessarily with learning carried alongside it. So some evidence of that, but we are in a highly prescribed curricular coverage terrain. We've talked earlier, and I think in the groups that broke up, several of the groups, I think, mentioned the kind of culture of teaching in South Africa. So the norm in South Africa, widely seen, is a highly teacher-directed form of instruction. And often that highly teacher-directed form of instruction does include a kind of choral, a collective chant learner input with some very closed questions on offer. Where teachers where teachers ask a question, they will leave a word unsaid at the end, and children en masse will chorus the end of that sentence. Sometimes children's answers are simply yes, ma'am, no, ma'am. But often it's the end of a sentence. It's a single number. Is it right? Yes. We often see a choral chant working like that. And we have on the ground the problem that we are dealing with and have been dealing with for a long time now, low levels of mathematical performance at all levels of our system. And all of those, I think, start to talk to some problems beyond task propensity that we have to deal with. Teacher knowledge is one of those issues, because teacher knowledge plays into some of the other issues that have been written there. But I think we have to dig deeper into the issue of teacher content knowledge and what we mean by that. And it might not just be a straight content knowledge and gaps in content knowledge that we have to fix. And for that, I'm going to take some examples from different studies. So this little example comes from one of our doctoral students in our team, is Corin Matthews, and he's been doing a PhD, which is looking at the teaching of division in grades 3 and grade 4. And this is one of the examples from his data set. There's an image like that, which is up on the board. And then we have a teacher narrative, which goes alongside that image. And the first question she asks is, among how many dogs are the biscuits divided? And 2 answers can be heard in this classroom. So one learner says 4, and another learner says 2. Teacher repeats the offer of 2, pointing to 2 of the brown blocks inside a square. The teacher then says, in how many groups have we put them? Now, we're not quite sure what that them refers to there, but the answer that she accepts is 4 groups. The teacher then says, well, who can give me a number sentence? And one learner comes up and he counts all of the brown blocks, and the teacher repeats that count, and she knows, okay, we've got 9 biscuits. So the teacher says then, 9 divided by 2 equals, and the answer 4, 1 remainder is offered by a learner and accepted. Now, we've talked a lot, we've written quite a lot about work in classrooms, instruction in classrooms that seems not to be quite coherent in the ways in which mathematical ideas are communicated. And we have got loads of examples that look something like this. Is this a teacher who doesn't understand division? We don't think so. This is a teacher who knows the answer to the question that she's aiming for. So it's not that she can't do the division, she can do the division. But in the instructional offering that she gives, things go slightly wrong. Because what we are unclear about, when she accepts 2 as the answer and points to the 2 brown blocks, it would appear that the 2 brown blocks are supposed to refer to dogs. We have to kind of take that on board. But then later on there's slippage, because then the brown blocks appear to refer to biscuits. And we have, and Corin has lots of examples like this in his data set, where we see, for example, a representation that goes up on the board. We see some teacher talk or some teacher instructional narrative that doesn't necessarily quite match the problem that goes up on the board. But not because a wrong answer necessarily is produced at the end. Because the answer that's accepted at the end, the 9 divided by 2 equals, 4, 1 remainder, is an acceptable mathematical answer to that question. Whether it's the correct mathematical answer to the task that was set in this case, we're less sure. But something has gone a little bit wrong, and we see lots of examples where things go a little bit wrong, something like this. There's another example, and this example again comes from Jill Adler's project, and she wrote about this in a book that was published last year that she co-edited with Anna Spard, where in a high school there was this example, an inequality example that was dealt with, x squared is greater than 4. And in this case, the teacher who was working this example quite quickly, having dealt with x squared equals 4 and produced the answers to that equation, went on for x squared greater than 4 to turn that into x squared minus 4 is greater than 0, quite quickly sketched the parabola to go with it, and then marked the 2 wings along the side, and then said, okay, now we'll deal with it algebraically. In dealing with it algebraically, at one point, and then repeatedly in the middle of this narrative, he used this line. This is the teacher talk that's reported in the transcript in the book. This and or thing is also confusing me. I'll take and. And they talk quite extensively in this book about this teacher getting confused about whether in the working and the solving inequality, when we choose one solution and another solution, and when we might take one solution or another solution. And in the chapter that Anna Spard writes in this book, she says that the teacher's narrative across this, and it seems to indicate his conviction that the choices of steps can only come from memory and require no explanation. And looking at the broader part of the lesson that's in focus across the book, She says references to mnemonics were numerous and frequent. So rules that had to be remembered. And it kind of harks back to the little cartoon that Kuna showed us this morning, which is mathematics as an act of faith. Results exist and we have to take them on faith. There were no reasons for when we might use and in the logic of the argumentation that produces the answer to this question. We simply had to take it on faith. And in this instance, the teacher said, well, I think I'll go for and, without any reasoning behind it. This is another example, and an example that we've written about earlier on from the primary school, and this links back to the task propensity issue, but I think we have task propensity issues at quite a lot lower level. So this was a grade 2 lesson that we saw early in our project work, where the task that the teacher had set their children in a grade 2 class was give me 2 numbers that add to 16. The children had cubes in front of them, and this is what transpired. Learners put their hands up and they offered answers. So 8 plus 8 was the first offer that was given. And the teacher said, well, can you use your cubes and check whether it works? The children made this combination, they checked, it was accepted and written up on the board. The next offer, 10 plus 6. Again, the teacher's response, can you check it by counting? 9 plus 9 offered. Not related back to 8 plus 8, we know that 8 plus 8 makes 16. Instead, check it by counting. And this goes on all the way through a series of examples. Every example was empirically verified by actually making the individual sum. So in our writing about that, we talked about, and we saw this again as reflective of quite a lot of the teaching that we saw, individual offers verified empirically through counting, rather than as a connected, derived set of results. And our naming of that phenomena, which again harks back to the task propensity idea, was an extreme kind of localization. Okay, where results get established for one question, but then we forget about that result and we don't have to use it and derive from that in our work going forward. The South African problem that's been most widely written about in primary schools is work that looks like this. And this is from Ursula Hoadley's work in the Western Cape. And she's got examples, as Eric Scholar has seen and others have written about as well, is from a grade 3 learner. We have lots and lots of incidents, both in the foundation phase, but well into our middle grades, of working that looks like this. So this is working for the question 214 plus 12, and we can see how learners are solving that problem. But if teachers are not going to work with establishing a result and then saying, what else can we learn? What can we derive from that result? Then an empirical verification is inevitable in some ways. Okay, that's the only thing you can do if results do not get established and work with. So, in terms of thinking about that and thinking about task propensity in the South African terrain, one of the things that we, I think, are talking about and thinking about is what does it mean to teach without a mathematical sensibility or a mathematical orientation? And what I mean by that is we've seen examples where the steps, the rules, the representations, they're arbitrary. Okay, and it's like that teacher who says, oh, well, I think I'll go for and. Rather than mathematics seen as reasonable, something that we can actually deduce and logically produce and deduce results from. We also have, as I've shown you an example of, gaps in the coherence of the narrative, although those gaps are often accompanied by what looks like a correct answer. But the production of that answer seems to go wrong, as some said. So once again, a narrative is produced where a correct answer gets written down, but not necessarily with a very mathematical narrative. And even in the early grades, we see task propensity issues at quite an extreme level, where very early mathematical results are taught as separate empirical results rather than as derivable and connected results. Well, what does that mean for how we might think about our teacher development, our curriculum, and our assessments on the terrain? Well, in the work that we're doing, we think it means that interventions to improve mathematics teaching need to build what we're calling a mathematical sensibility. And for us, that means supporting teachers to teach mathematics in mathematically coherent and connected ways. It's the coherence that is going to allow us to see that a mathematical orientation drives the production of results. And the connection is what's going to overcome, or start to overcome, some of the task propensity issues that we've got going on. So going back to Kravenmeyer's work, they said, and in their terrain, in the Dutch study, in that paper, they said in their terrain, the students had developed well-grounded ways of solving a specific set of problem types, but they could not manage tasks that transcended this set. Now, I point that out because I've said there are overlaps in the problems that we have with task propensity. But I don't think we yet have the luxury of seeing, in a very wide way, those well-grounded, informal ways of solving a specific set of problem types. When we look at the results on our terrain, whether they be at the end of primary, or actually even early in primary, quite often what is lacking is any sense of a well-grounded sense-making of particular problems. So in our work with task propensity, we have to take that issue into account. In Kravenmeyer's work, they say that in response to the task propensity issues, their solutions are the emphasis should be on curricula focused on what they call advanced conceptual mathematical goals. And there's a section at the end of the paper which clarifies what that means. And they say in the paper that this is not the same as a focus just on conceptual understanding or on high cognitive demand tasks. And their argument is that the curricula framed without these goals, without these advanced conceptual mathematical goals, and textbooks that miss attention to that emphasis, which in RME, on these advanced conceptual mathematical goals, while noting too that RME probably didn't do enough work in the early stages to attend to an explication of what those goals might look like. So that the attribution in the paper is to curricula that hasn't addressed this issue, and then textbooks that have failed to address this issue as well, with some kind of ownership that maybe RME didn't do enough in the early grades to do that. So, what does that mean, again, coming back to our terrain? Well, the advanced concept, what does it mean? Because it's a nice phrase of advanced conceptual mathematical goals. Looking at the paper, what we can see, and I think what we heard this morning is, what I think was meant in that paper by these advanced conceptual mathematical goals is a foundation in reification of processes into objects. Many of us have read Anna Svab's work, and that's cited in Kuhner's paper. And what it means to have reifications of processes into objects is we then build objects that we can talk about, objects that are talked about as reified objects rather than as processes, but that in the work going forward and following on from Anna Svab's early work on the dual processes, that we end up with a structural sense of mathematical objects linked and nicely linked and well linked to an operational sense. In terms of the number work, and I'm going to focus on the number work because we're working particularly in primary where number work is writ large, there are some examples in the paper, and they say in the context of the number work that, in short, numbers, sums, differences have to become mental objects that can be composed and decomposed in different ways, which in turn forms the basis for flexible arithmetic and an expansion to bigger numbers, and later for integers and for algebra. So in their response, in the Dutch response, the aim is to intervene through a focus on improving the curriculum specification and improving textbooks. What does it mean in our terrain? Well, we've got people in this audience, and there's a lot of thinking currently about curricula, and I think we can go. The curricular route is one way to go. Textbooks potentially as well, in a context where we have national textbooks now, and national workbooks certainly for the children. I think to think a little bit more carefully about what we put into those is certainly an avenue that we could be looking at. But I'm going to focus particularly on the teaching side of things. What does it mean to teach in ways that might address these issues?